Okay, I guess I have everybody's attention because it's lunchtime. So my name is Bob Laramie, and I'm going to speak for about 2 hours. I'm coming from the Department of Computer Science, and I'm working on data visualization. So one of our projects is studying healthcare data, and I think most of the people in this room are very familiar with the nature of healthcare data and the challenges it brings. Now, this is the more the information visualization side, or the electronic health records side of the healthcare story, as opposed to the scientific data side. So the healthcare data brings with it a lot of challenges, right? It's heterogeneous, it's complex, it's time dependent. It's usually decoupled from its location in the visual representation, and it's very big, right? It's very big, and these are some of the challenges that inspire us to apply data visualization to see if we can derive some special insight or some special new knowledge in that complicated data. And so we're working on developing novel data visualization techniques. So has anybody here heard of data visualization before? I think a lot of people have. Right, so data visualization is good for exploration. If you're not familiar with the data and you want to find some patterns or search for trends and outliers. It's good for analysis. That's if you want to confirm or refute a hypothesis that you already have, or a question you already have in your head. It's good for presentation, which is what I think most people associate with data visualization and what we're going to look at today, hopefully. It's also good for acceleration. So if you want to find something, you can find it much faster if you're looking at an image rather than numbers. So you can find things in images in just a few seconds that might have been impossible to find by just looking at raw data. It's also good at increasing confidence. So when you can see what you're doing, when you can see the data, suddenly you can confirm if what you're doing is correct or incorrect. So data visualization is very good at finding errors in your data collection processes. Anybody ever heard of Treemaps? So this is going to be like the world's fastest introduction to Treemaps, maybe. So Treemaps are a kind of a standard and traditional visualization, data visualization approach for hierarchical data. So this is a standard hierarchy, and that hierarchical data has been transformed into a geometric shape called a tree map. Every node in the hierarchy is mapped to some rectangle here. So this root node in the hierarchy is mapped to this outer rectangle. That's the whole, usually this is mapped to the whole screen, whichever screen you're looking at. And then it's recursively subdivided. So this leaf node, which is a child node, is mapped to a rectangle right here. It has no children, so it's not subdivided any further. This leaf node is mapped to this rectangle. This is an internal node. It's subdivided into 5 rectangles, so the internal node encompasses this space, and there it's 5 children, and so on. Did I lose everybody? Hopefully. So these tree maps have nice properties. They fill the space, they fill your screen space, they utilize it properly. They can represent hierarchical data, they can represent multivariate data, and they can represent very large data sets. But they do have some limitations. They usually don't represent geospatial information, so it's nice to see geospace coupled with your electronic health care records, like where in Wales are people really obese, for example, right? And they don't preserve neighborhoods, which is very closely related to the geospace. Again, the world's fastest introduction to cartograms. Has anybody ever heard of cartograms before? Probably you all have seen cartograms before, but you just didn't know that they were called cartograms. So this is a map of the UK, and it's divided into regions. And it's very common to take those regions and assign them a color, right? And the color usually indicates something, like population density, for example, or some healthcare prevalence. The problem with the traditional, these are called choropleths. The problem with the traditional choropleths is in the densely populated areas, it's hard to see anything, like in London and Cardiff, and because the data is too dense there by definition. Right? We're usually looking at people, so the data is usually too dense in capital cities and in densely populated areas. So one way to address that limitation is with cartograms. So cartograms assign some sort of shape to every unit area. In this case, it's a sphere. And then the radius of that sphere is mapped to some property. It could be it's usually population, but it could be anything. It could be any healthcare attribute. Right? Here we see a cartogram of the UK. It represents the same data, right? But now the data, the map has been distorted, right? London has exploded, so we can see what's happening in the population of London. And same with the other big cities, right? So there's a trade-off between the accuracy of the geospace and the accuracy of the data representation. So cartograms they include the geospatial information, which is nice. Everybody likes to look at maps. They're very engaging, right? And they increase memorability, right? If you decouple the data from the maps, it's harder to remember. They're not necessarily space efficient. They're usually univariate. They introduce geospatial error, and usually they're not hierarchical. So we are trying experiments to see if we can combine the advantages of tree maps and cartograms together, to see if we can combine or create a visual design that includes geospatial information, it's space efficient, or utilizes the space as best as possible. It can represent multivariate data, it's hierarchical and engaging. We call these cartographic tree maps. And we're applying them for this special case of public health care data, right? So we can study things like coronary heart disease, heart failure, stroke, chronic kidney disease, diabetes, hypertension, and so on across the UK, right? That's a preview. So Public Health England releases massive amounts of public health data, and it contains millions of records, it's multivariate, and it tries to represent all, in this case it's all of England. And this is a typical data visualization that's representing, for example, cancer. Right? But the geospace is missing, right? It's univariate, the geospace is missing. It's not very space efficient, so the data is all clustered in one spot on the screen. A little bit more about this data. It's divided into clinical commissioning groups. There are 209 clinical commissioning groups across the UK, and they collect prevalence values. Every time somebody's diagnosed with cancer or coronary heart disease, hypertension, diabetes, that is recorded and stored in their databases. They collect and archive the information, and then they release it to the public. And they're looking for people to come up with some innovative representations of the data. Right, so these are cartographic tree maps, and I'm going to show a demo actually, rather than just slides. I actually don't like slides. I prefer things that are moving. And if I can find the movie, I will show it. We won't have time to look at the whole thing, but this just gives you an idea of what the software looks like that we're working on. So basically, these are all CCGs, right? And there's a layout algorithm that places them in space, in geospace. And the user has control over how much space the map covers, how much screen space the map covers. But there's a trade-off. So the more screen space you occupy, the larger the geospatial error that you introduce. So the user has explicit control over this trade-off between geospatial error and screen space representation. So every CCG is allocated a rectangle, and then inside the rectangle it's subdivided again using the Treemap properties. There's a subdivision into smaller rectangles, and each one of those represents some prevalence value, some diagnosis. So for example, by looking at these cartographic tree maps, we see right away hypertension and what were the two? Hypertension and diabetes are extremely prevalent all across the UK. We can see that immediately with these cartographic tree maps. These are the nodes being laid out, and their size reflects the population, the size of the population that they're meant to serve, right? And as soon as we map that to population, we can see, for example, we find actually the largest CCG is in Cornwall as opposed to London, where we would expect it. And this is just demonstrating that we can actually group the CCGs together into regions and create a hierarchy. We can click on any CCG and then get the original data values. So the name of the CCG and the number of cases and diagnoses found in every group, right? And I know everybody's hungry, so I'm not going to go through the whole demo. Probably you're wondering, is it possible to see the whole demo even though I'm going to eat lunch now? And the answer is yes, because there's a copy of it on YouTube. You might have to compete with the millions of other people that are trying to watch the same video at the same time, but there's a copy of that on YouTube for anybody that's interested as well. I think we'll stop now.